lesson 2, we're going to take a look at interactive feature recognition today. So we're going to start with this part here. It's mil2ax_1. It's a file that you've seen before. It's in SOLIDWORKS CAM training. It's also in some of the other things that we do with SOLIDWORKS. So we're going to start with this file. I just already went through and did an import. If you need to remember how to import, please refer to lesson 1. But we're going to take this file and we're now going to move over to DELMIA and go through the process of programming it. So with the file open, I'm going to start by going down, picking my shop floor machining app. And this will take the file and automatically create the PPR and get me on my way to start the programming process. Now, one thing I'm going to do is I'm actually going to close this PPR here. I don't need that one anymore. So we'll just keep the mil2ax and the new one that we created up. In later lessons, we'll talk about how we can reuse the original one that shows up. But for today, the easiest method is to open your part, click on the compass, click the DELMIA machining app that you want to use, and it'll automatically create your manufacturing product, and it'll put your part in here in the NC assembly folder. So just like lesson 1, we'll start by picking a generic machine. We'll just do a simple 3-axis on this because the focus of this lesson is one of the methods of feature recognition. So I'll just hit OK. That creates my machine, and then we'll start by creating our stock. Here's my box. I put it over here on the left just because sometimes it's easier to navigate. So I'm going to go to my tree. I'm going to pick where I want the new product to be created or the new rough stock to be created. So I'll put that in this location, and then I'll pick the part. It'll automatically create the bounding box. For this set, I'm fine with just leaving it stock. So it just creates our bounding box there. And now we can move to part operation. And if you remember from lesson 1, we'll talk about how these go away and come back. But I'll start by picking my rough stock, pick the stock, double click. And then I'm going to use my action pad to hide the stock. And then I'll pick my part. And now I have my stock and part. If I want to move the coordinate system, like let's say, we'll pin this guy out. Let's say I want to set the coordinate system in the corner. I can grab this dot, pick the corner of the part, that'll put it on the stock. And then if I wanted the X axis to go along this method, I can reverse it, hit OK. I can put in a name here if I wanted to. If I'm not using kinematics, this is where I can put in my work offset numbers, so like G54, hit OK. And I now have my G54 defined. That'll get it output when I post later on. So we have our part, we have our stock. There are a couple tools we're going to create, and then we're actually going to leverage a tool that we used in lesson 1. So we're going to move down to resource creation, and we're going to start by just picking a face mill. And if you're in metric, I believe this comes out to 100 or 200. For this lesson, we'll just go ahead and leave these stock, but I'm going to change this to change the naming convention here. So I'm going to do T1 face mill. And I'm going to do that just because that way later on I can reference this. In the description, I'm going to put lesson 2 because over time as I program my own parts, I want to make sure that I don't accidentally use this one and not have it match something that's actually in the real world that I'm using. So we'll just select OK, and our face mill has been created. And from here, what we're going to do for this just right now is we're going to close that. So it takes us back to our original. And again, I'm going to use my action pad, hide the stock. And in this lesson, you'll notice we have some holes that we want to drill. So one of the things that I do want to show you here, if we're not using like automatic feature recognition or anything, is some of the options we have down here at the bottom. So under the Tools tab, there's actually some options for measure. There's measure between, and then there's the dial calipers. If I click the dial calipers, I have the ability to come out and measure different items. So if I pick that hole, it gives me this size here. And again, I'm in inches, so it comes out to 787. I believe it's 20 millimeter if I remember right, or 10 millimeter. So you can use this measure tool in a couple different ways. There's some cool things you can do with this. You can do filters like you would in SOLIDWORKS. You can do axis systems. There's a bunch of settings in here. This is a really cool measure tool. I recommend that you spend some time, play with it. There's some fun things you can measure in this option. But for this example, I just picked the cylinder. It gave me the radius, diameter, and then it gives me the area. So what we need to do is we actually need to create a 10 millimeter drill, or a 787 if you're using inches. So once that's there, I'm actually going to go back to my wizard, go to my tools, and I'm going to do another resource creation. And this time I'm just going to pick a regular jobber drill here. So I'm going to go to my drilling items section, go to my jobber drill. I'm going to call this T2 10 mm jobber. In my description, I'm going to put less than 2 also, because this may not be one that I want to use down in the future. And then for the diameter and some of those offsets like here, I'm going to use inch, but 787 or 10 mil. You could also type in 10 mm, and if you hit enter, it automatically converts it to the number that you want it to be. And I'll change the shank on this. I'll select OK, and now I have my 10 millimeter jobber as well. So for resource creation, that's what we're going to have today. Is we're just going to have the drills, and then we're going to have the face mill, and we'll worry about the pocketing here in a little bit, and we're going to actually bring in a tool from a previous from lesson 1. So from this point, what I'm going to do is I have my stock, I have my machine, I have my part, I have a couple tools. So the next step we're going to take a look at is local feature recognition. So I'm going to go to axial machining. And one thing I will do here is I'll turn on some of the icons so it's easier to see. So in axial machining, I'm going to come over here, and there's an option for local feature recognition. Now there's a couple different ways we can recognize features in geometry. For this lesson, we're just going to focus on local. So I'm going to pick local, and then we have the option to pick the type of feature that we want. And if you think of like SOLIDWORKS CAM or SOLIDWORKS where we define different features, we can pick the style we want, and then that sort of classifies it so we can use it downstream if we wanted to do rules-based machining. So for this example, we're just going to we'll just do complex pocket. And then the way that this works is you pick faces for local feature recognition. So I can pick different faces on the part. If I go to advanced, then I can define a machining direction also. There's a couple different ways you can use this. So I'm going to pick the bottom face, and you're going to get this option right here because it's going to say, hey, your material right now, you're going to try to machine it from the bottom, which isn't what we want. We actually want the arrow to go up because that's the bottom of our pocket. And then from there, we're going to pick the top. We're going to hit recognize. And then it says number of faces used in the features 27, input faces 2. We'll hit OK. And if I come over here and I look, I now have a prismatic machining area. And you'll notice when I highlight it, it has all the faces that intersect the top and bottom. So just that easy, if I pick the bottom and the top, it'll automatically define the feature, which is a very similar thing to what we get with SOLIDWORKS CAM as an example, or feature recognition in SOLIDWORKS. So once I have that one, I'm actually going to go through and I'm going to go through this set again. So I'm going to pick the bottom face. I get the message for machining direction. So we'll change this to go the correct way. We'll pick the top. Hit recognize. It now found 10 faces in that example. And you'll see that it found these 10 faces. That's now part of our prismatic machining area here. And then we just keep repeating that process. In this instance, I have the Z going the correct way. So I'll zoom in, I'll pick the top face. And we're just building out these manually or interactively. Now, if I set a default machining direction here, it'll help with that error message that comes up. But for this lesson, I'm just going to hit OK to that, hit OK to that, recognize. And then the last one I'm going to do is this one. So we'll change that to the top Z. We'll change this to the top Z. Recognize. And we should end up with different groups or different features that we'll use for machining. I'll zoom out here a little bit. Now, what's cool about this too is, let's say I accidentally selected the wrong thing. I can right click on any of these and go to edit. And what that'll do is it'll actually bring up our dialog box here. And you can see that we can change what the top is, what the top face is, what the bottom is. If I look at the guide curves, you can see I have a guide by faces. Those things are all there, and I can make changes to them if I need to. I can also change the type, whether it's a pocket, a closed pocket, whether it's a through pocket or a closed pocket. Here, I have the ability to come back and make changes to that geometry. You'll also notice by using feature recognition, I know what the minimum corner radius is, so I know how small of a tool I can pick. I know what the depth is. I know if there's a fillet at the bottom. All the information that we use in SOLIDWORKS CAM or in feature recognition with SOLIDWORKS, all that information comes through automatically by just picking two faces and hitting OK. It automatically grabs all the necessary information that's here that I can leverage later on down the road for automation. Now, one of the other things you can do too is you can come in here and you can rename these. So if I come here and I go to edit again, I got a little ahead of myself. Here where it says prismatic machining area under this gear, I can change that to be pocket 1. And if I hit OK, it now changes it to pocket 1. So on any of these, you have the ability to make changes to the name and really customize this if you want to. Some people are very picky about names and how they're sorted when they program. That can be done here. And one thing I'll point out too on this one is you'll see when I pick the bottom face, it automatically found the islands too. So you can automatically find islands in a part if you want to machine by just picking two faces. You can rename these, use them however you want, but it is important to understand that that's how the interactive feature recognition works. So with the features and the setup out of the way, let's start putting an operation on. We'll start with a face mill. Now, to do a face mill with shop floor programmer, we're actually going to use the pocketing operation because facing and pocketing are sort of the same thing. It's an open pocket versus a closed pocket. So we're going to go to our operations in Prismatic. We're going to click on our pocketing, just pick out on the part somewhere. And that's going to bring up the ability for us to click a tool. So we're going to go to our face mill, which is right here. So I'll filter to a face mill. Then I'll click the select from my local, and I'll pick the face mill that I had earlier. And now it's going to ask me to pick a feature in the part. So I can either pick a predefined feature that I have in the list. I can manually create machining areas if I wanted to, but for this instance, I'm just going to click this button, and this is going to allow me to actually then just pick the geometry that I want on the screen. So when I click that button, it takes me to here. I'm going to start by picking the bottom. I don't want to go below that face. And then I'm going to pick a guide area. I'll move my dialog up here. And that way it'll be there next time I want to use it. And we'll go pick the outside. And we'll hit OK. And we now have our bottom, our guide. And down here you can see that we have the option for an open pocket. The bottom is hard, which means we don't want to go below that. And then because I have a boundary and I'm using a 100 millimeter face mill, I'm going to go -2 inches on the outside or -50 millimeters on the outside. And what that'll do is it'll allow the tool to go past that guide. And then we want to start on the outside, and then I'm going to do a 1/4 inch or 250 thou approach clearance. You can adjust this to whatever makes sense for you. But the cool thing is all these settings allow it to be open, and then we can start on the outside. For our strategy, we're going to go to the third tab, and we're going to do a back and forth because that's generally what we do with the facing, right? We go back and forth across the part. And then in the back and forth, we're going to go down to radial. And here's where I can set how much my step over is, if I want any overhang, overhang past. And then I'm going to turn on avoid scallops, so that way I don't end up missing a section as I go back and forth. You can do some more things like contour path, truncated path. There's a lot of settings that you can do in here to really fine tune or dial in the facing that you want. The last area is if I go to approach and retract. If I turn on the approach, then I have the ability to do like a horizontal, axial ramping. I can build my own custom one by clicking the pencil here. For this example, I'm just going to do horizontal, and axial. And then when it retracts, I want to do the same thing. That way it just goes, it comes down, moves over, and then moves into the cut. If you wanted to do clearance to make sure that it retracts above to a clearance plane all the time, you can do that as well. All these can be turned on and off depending upon, what settings that you want to have. So from here, I'll just select OK. That creates my pocketing. Now I'm just going to highlight it. And for this example, I'm just going to compute the tool path. So it's here. And again, we talked about the showing of the tool paths in lesson 1. If I go to my app options, I have the ability to turn on tool paths when I pick on the operation. That's what I have here. If you don't know where the app options are, if I go to tools, there's a button right here that turns it on or off as well. So you can do it different ways. I have mine actually docked here because there are times I want this on, I don't want it on. So that's our first area. And again, I should mention, it says pocketing 2. If I want to organize my tree to make a little more sense to me, if I wanted to do that, I can click in the operation. I could change this to face mill. Hit OK. And now the name will be changed to what we want. So we have our facing. The next thing that we have is, or the next thing we're going to do is we're going to focus on some of the features that we created in here and some of these from feature recognition. So the pockets and then these components. So we're going to use pocketing again. So I'm going to click the pocketing command and then I'm going to click out on the part. And you'll notice when I started, I didn't start in the operation. So let me back up here. So if I had this still highlighted and I start, it'll drop it in and it'll automatically accept the tool. There's no problem in that. I can also click out of it to another area, and then when I click on it, it sometimes will give me an option to select the tool up front. Either way will work. It doesn't really matter, to be honest. So if I click my pocketing option and I click on the part, if it jumps to adding the pocket underneath automatically, like here, it's automatically looking for a feature. So we'll go through this and I'll show you how to pick a tool. So we're going to go for the manufacturing feature. We're going to click a pocket. We'll click the pocket 1. And by default, it's automatically picking a face mill. Well, we don't want to use a face mill for this. We actually want to use a tool from our library. So if I click on the name here, it takes me back to that original tool search. Now, at the beginning of the lesson, we talked about going and grabbing an end mill that we used in lesson 1. So I'm going to change to an end mill type. And then what I want to do is I want to go search in the database. And this will allow me to search in my common space and find any tool that I've used before. So when I click this, it's going to take a second. It's going to bring up a search. Here's the search. So what I can do up here is I can search for NCT. And that will bring up all my cutting tools that I've created. And then from here, I have the ability to search for all types. If we don't want to use NCT, I can also do my content, and this will filter by tools also. I believe NCT is already filtering. Yep, the NCT is already filtering. So here you can see I have lots of different cutters in my library that I can pull from. What I want is I want to search for one that is lesson 1. And I believe I have a tool with lesson 1 right here, sample end mill. If you remember from lesson 1, when I put in the description lesson 1, this now allows me to make it easier to find over time. So what I'm going to do here is I'm going to click this tool, and shop floor programmer is now going to add this to my current working session. So it's going to go grab it from the library, copy it over, put it in this PPR, and now I have it to work with. Close my search window. Close the tags too. So now I have the ability to swap to that tool, and in the feature designation, all of the features are already taken care of. It's already a closed pocket. One thing I will do is I will set the boundary to 0. I'll hit OK. I'll do a quick screen refresh here. And now I have that tool change with the sample end mill. I have my pocketing, so I can click on that. I can compute the toolpath, and now when I look at it, I have my toolpath created to machine that part. Now you'll notice that I have a back and forth on this. Because I originally had my face mill up here, I'm copying those settings over to this one. So what I can do to make my life easier is I can open this up, just double click on it again, and I will go to my strategy page and we'll do outward helical. We'll keep those, that'll be all right. I think if we just go to outward helical, we'll be okay. I'll select OK, and then I'll compute it. We'll see if that one looks a little more like what we want for a pocket. There we go. That looks a little bit better. Now, for the rest of these, I can just click pocket, click the feature, click OK, and all the settings will apply. You can also copy and paste these and then just change the feature. What I found is once I have the feature created, I just highlight where I want it to go. So I want it to be below pocketing 4. So I'll just click my pocketing button. It'll automatically inherit all the operations and settings that I want for this one. Now I can just go down the list and say, well, I want to use pocket 2. Hit OK. We'll do pocketing again. I want to put another one below it, so I'll just highlight it from the tree and it'll drop it in that position. And again, it's copying all those settings. So we'll do machining area, click pocketing. So if I program the first one with all the operations and settings I want, then I'm really just going and picking all these unique features, and everything gets inherited along the way. Now I can compute the toolpath and look at them, but for this lesson, I'm just going to compute them all here at the end. And I believe we have one more, so I'll do the 5th one, select OK. And then I can click on the top. I can also shift select the ones that I want, compute toolpath. And now I have all of those machined. And you'll notice from the feature recognition, we're also automatically going around the islands. So it takes longer to explain than it does to program. But the benefit here is once I have the features identified, if I set the operation up the way that I want, feeds and speeds, depth of cut, step over, then it's really just selecting the different features in a way that I program. Now, one of the things that's worth mentioning is if I'm in the operation, and I wanted to go to a different feature, if I click here, it allows me to go back to this tree and pick different geometry. So even though I selected this originally, I have the ability at any time to change what geometry I want to use for this operation. You're never stuck to have to delete and redo. I can just open up the operation and then I can go ahead and just program the part. So our last step we're going to take a look at is putting some of those holes in here. So we're just going to go to our drilling operation. So I'm going to pick my drill, pick on the part. It's going to ask me to pick the holes that I want to drill. So I'm just going to pick the holes. Rotate here a little bit. So we'll pick the holes that I want to select. Now I could use feature recognition for this, but I only have 5 holes. I'm just going to manually pick them. So I'll double click when done. That'll automatically grab the holes in the axis. I'm going to change my tool. So I'm going to go to the first tab. click on our end mill. Now I want to use a drill. If you remember, we created a 10 millimeter jobber drill. So I'm going to pick that one from the tree. And then I have the ability to add a part surface. I can do check surfaces. So I can check where it's going to be. There's also extensions if I want to have how I want the holes to be handled here. If I go to strategy, I have drilling, dwell, break chips, deep hole. And then I can adjust based on tip or depth. So I'm going to come back here and I'm going to pick the whole bottom, how deep I want this to be. So that way all the holes will just go to that standard bottom. If I had different depths, I can set different blind through holes here. And then I have the ability to adjust the depth for each hole. We'll select OK. That now puts another tool change in on our drilling. I'll first compute the tool path. And now I have my drilling cycle that I'm going to drill with. So walking through this, the operations are the same as we've always done. The only difference in what we have right now is by using the features, I just go define the features I want to machine, and then I just pick the operations and away I go. And from there, that concludes lesson 2 with interactive feature recognition.